6.2.3 Pre-AP Layers of Earth and Tectonic Plates Exam. Number 1. A map of some Earth plates is shown below. The letter D on the map above represents which of the following plates? So you should circle D right here. Is it A, the Eurasian plate, B, the South American plate, C, the North American plate, D, African plate? We're looking for this continent. Which one is it? All right, number 2. The tallest mountains in the world are the Himalaya in Asia. Because of the movement of the tectonic plates, the Himalayan mountains are still rising. Which type of tectonic plate movement is responsible for the creation of the Himalayas? A, the collision of two tectonic plates. B, the collision of a plate with an oceanic plate. B is the collision of a continental plate with an oceanic plate. C, the separation of two continental plates. D, the collision of two continental plates. So what causes the Himalayas? Collision of two oceanic, collision of continental and oceanic, separation of two continental, or collision of two continental. During the year 2003, the number of earthquakes that occurred was higher than usual. The map below shows the locations of some of these earthquakes. Why do the dots on the map tend to form a long, curving line along the western edge of the Pacific Ocean? Hint. Step 1, identify the structures of the Earth along the edge of the Pacific Ocean. Step 2, relate these structures to the cause of earthquakes. So, step 1, identify the structures of the Earth along the edge of the Pacific Ocean. So that's what we're looking at there. Okay. Step 2, relate these structures to the causes of earthquakes. So, the question reads, why do the dots on the map tend to form a long, curving line along the western edge of the Pacific Ocean? Right here. A, the high rate of hurricanes and typhoons can cause earthquakes. B, the boundaries between two tectonic plates can cause earthquakes. C, the high rate of tsunamis can cause earthquakes. D, the weight of water can cause earthquakes. Number 4, the San Andreas Fault is a transformed fault. The map below shows a student's approximation of where the fault line crosses through the United States. Students were asked to make maps predicting which way the land would most likely move over thousands of years. Which map best predicts the likely movement of land along the fault line over thousands of years? A, movement toward the east. So the Pacific Plate moving east toward the San Andreas Fault. B, mountain building. So we have both plates moving in one direction. C, spreading along the fault line. We have the North American plate moving east away from the Pacific Plate. D, movement along the fault line. So we have one plate moving in one direction and another plate sliding in the other direction. So, which of those best describes a transform fault? Transform fault. Number 5, earthquakes are vibrations that move along through Earth's crust. Which of these causes earthquakes? A, tectonic plates slamming together at high speeds. B, tectonic plates slowly sliding against each other. C, a tectonic plate splitting in two. Or D, a tectonic plate flipping over. Number 6, a student uses a piece of clay to model the slow collision of one continental plate with another. What would this kind of plate movement cause? So we have two continental plates colliding. A, deep sea trenches. B, volcanic islands. C, folded mountains. D, rift valleys. Number 7. Rift valleys can form when fractures in Earth's crust widen. The valley walls slowly move at a rate of only a few millimeters a year. Which of these best describes the type of tectonic activity that forms rift valleys? A. Rift valleys form where continental plates moves under the oceanic plate. B. Rift valleys form where plates slide horizontally past another plate. C. Rift valleys form where two plates move away from each other. D. Rift valleys form where an oceanic plate moves under another oceanic plate. Number 8. Look closely at the map below. What caused the geologic feature known as the Andes Mountains to be formed? A. The Nazca Plate pushing against the South American Plate. B. The Antarctic Plate sliding past the Nazca Plate. C. The South American Plate moving away from the Nazca Plate. D. The African Plate moving away from the South American Plate. So here's the Andes Mountains. Here's the Nazca Plate. Here's the Antarctic Plate. Here's the South American Plate. Here's the Caribbean Plate. And here's the African Plate. So, what formed the Andes? The Nazca Plate pushing against the South American Plate, A. B. The Antarctic Plate sliding past the Nazca Plate, B. C. The South American Plate moving away from the Nazca Plate, so this one moving away from this one. Or D. The African Plate moving away from the South American Plate. What caused the Andes Mountains? Number 9. Study the diagrams showing how diverging continental plates can cause a geological event. The diverging oceanic plates ultimately become A. Mid-ocean ridge, B. Ocean mountain range, C. Underwater trench, or D. Earthquake. So here we have the diverging oceanic plates. So this is how they start out. They move apart more, and this is how they end up. What is this? A mid-ocean ridge, an ocean mountain range, an underwater trench, or an earthquake? Number 10. A mid-ocean ridge separates the Pacific Plate and the Nazca Plate off the western coast of South America. Which statement best describes the relative motions of the Pacific and Nazca Plates? A. The Pacific and Nazca Plates are both moving to the east. B. The Pacific and Nazca Plates are both moving to the west. C. The Pacific Plate is moving to the west, and the Nazca Plate is moving to the east. D. The Pacific Plate is moving to the east, and the Nazca Plate is moving to the west.